Over voltages in electrical power systems. 1. What are the chief causes of over voltages in electric power system? 1. Lightning over voltages, natural causes. 2. Switching over voltages, system-oriented causes. 2. How are switching over voltages originated in a power system? Switching over voltages originate in the system itself by the connection and disconnection of circuit breaker contacts or due to initiation or interruption of faults. 3. What are switching over voltages? Switching over voltages are highly damped short-duration over voltages. They are temporary over voltages of power frequency or its harmonic frequencies. They are sustained or weakly damped. They originate in switching and fault clearing process. 4. For ultra-high voltages, perhaps, switching surges may be the chief condition for design considerations. Why? The magnitudes of lighting voltages appearing on a transmission line do not depend on line design, hence lightning performance does not improve with increasing insulation level, that is, the system voltage. On the other hand, switching over voltages is proportional to operating voltage. Hence, for ultra-high voltages, switching surges may be the chief condition for consideration. 5. State the parameters and characteristics of the lightning strokes. 1. Amplitude of currents. 2. The rate of rise. 3. The probability distribution. 4. Wave shape of the lightning voltage and current. 5. Time to peak value. 6. How are lightning strokes on transmission lines classified? 1. Direct strokes. 2. Inducted strokes. Direct stroke. Black circle. When thundercloud directly discharges onto a transmission line tower or line wires, it is called direct stroke. This is the most severe form and this occurs rarely. Inducted stroke. When thunderstorm generates negative charges at its ground end, the transmission line and tower develop induced positive charges. Normally lines are unaffected because they are insulated by string insulators. However, because of the high field gradients involved, the positive charge leak from the tower along the insulator surfaces to the live conductors. After a few microseconds, say, when the cloud discharges through some earthed objects other than the transmission line, huge concentration of positive charge is left with. The transmission line and earth act as a huge capacitor. Black circle. This may result in a stroke and hence the name inducted lightning stroke. 8. Give the mathematical model for lightning. Let low lightning current source, Z object impedance ZO source impedance of the cloud, V voltage built across the object trail line. 300 to 500 ohms ground wire, 100 to 150 ohms tower, 10 to 50 ohms. Therefore ZO less and can be neglected. Where low lightning stroke current, therefore V equals IOZ, Z equals surge impedance. 9. A lightning stroke 10 kA strikes a line of 400 ohms surge impedance. 1. What is the over voltage caused? 2. If a direct stroke occurs over the top of the unshielded trail line, what is the over voltage? Case IV equals IO. Z equals 10 kA 400, 4000 kV. Case 2 SCETV equals low, Z, 2, equals 10 by 400 kV 200110. What is thunderstorm days? Thunderstorm days TD is known as the isochronic level, is defined as the number of days in a year when thunder is heard or recorded in a particular location. The incidence of lightning strikes on trail line, substation in related to TD. TD is 5 to 10 in Britain, 30 to 50 in USA, 30 to 50 in India. 11. What are the causes for switching surges? 1. making and breaking of electric circuits. 2. Initiation or termination of faults. 3. Energization and de-energization of cables, capacitors, transformer, reactors, load etc. 12. What are the effects switching surges on power system? Power system has large inductance and capacitance. Black circle switching surges may create abnormal overvoltages, 6 times. Black circle switching surges with a high rate of rise of voltage may cause repeated restriking of the arc between the CB contacts and damage the contacts. They have high natural frequency components and damped normal frequency component. 13. Explain the mechanism of switching over voltage in EHV system. Switching over voltage are generated when there is a sudden release of internal energy. This happens where 1. Low inductive current is interrupted, transformers and reactors. 2. Small capacitive current interrupted, unloaded lines. 3. Ferro-resonance condition. 4. Energization long EHV lines. 14. What are the measures taken to control, reduce the switching over voltages? 1. One-step or multi-step energization of lines by pre-insertion of resistors. 2. Phase-controlled closing of circuit breakers with proper systems. 3. Drainage of trapped charges on long lines, by discharging, before the closing of the lines. 4. Limiting overvoltage by surge diverters. 15. What are the causes for power frequency over voltage in a system? 1. Sudden loss of loads. 2. Disconnection of inductive loads. 3. Ferranti effects and unsymmetrical faults. 4. Saturation in transformers. 16. Name the various methods for protection of transmission lines against lightning over voltages. 1. Shielding the overhead line using ground wires. 2. Using ground rods and counterpoise wires. 3. Using protective devices like expulsion gap, protector tubes, surge diverters at appropriate places. 17. What is a ground wire in a transmission system? Black circle ground wire is a conductor run parallel to the main conductors of the transmission line, supported on the same tower and earthed every equally and regularly spaced towers. It is run above the main conductors. It shields the line conductors from induced charges and lightning discharges. The shielding angle should be less than 30. 18. Distinguish between an expulsion gap and a protector tube, value type LAS. In the expulsion gap type there is no non-linear resistance. 19. What is the purpose of insulation coordination? 1. Electric power supply should ensure reliability and continuity. 2. At the same time cost should be low. 3. A gradation of system insulation and protective devices operation is needed, keeping in view of the importance and cost of equipments, duration of interruption etc. Hence the need for insulation coordination. 20. The volt-ampere characteristics of a non-linear resistor used in a surge arrestor is given by V equals K, in where K and N are constants. N equals 0.5 to 0.6 for silicon carbide, N equals 0.02 to 0.03 for ZNO. For silicon carbide, N equals 0.5 to 0.6, which is not enough to limit the power frequency follow-on current within limit. Hence spark gaps are used, whereas for ZNO, the characteristics is such that even without the spark gap, the current value can be limited within the value. Gapless lightning arrestors. 21. Give the wave shape of a standard lightning impulse and a standard switching impulse voltage. Standard lightning impulse voltage 1, Vp equals peak value. Tolerance plus 3% to TF equals front time 1.2 microseconds, 30% 3. TT tail time 50 microseconds, 120% standard switching impulse voltage 1. VP tolerance plus 3% 2. TF 250 plus a minus 20% 3. TT 2560% 22. For proper protection, how should the ground wire be positioned? 1. They should be positioned at a height above line conductors such that they intercept the lightning stroke. 2. The phase conductor should be in the protected zone, within a quarter circle with the radius equals the ground clearance and center at ground wire 3. The shielding angle should be less than 304. There should be no side flash over 5. Tower footing resistance should be low to prevent back flash over 23. What are counterpoise wires? Black circle horizontal wires buried at a depth of Lm in the ground. They may be parallel to the conductors or radial from the tower footing. Black circle, they are to reduce tower footing resistance. 24. What are ground rods? Additional rods provided driven into the ground near the tower footing and connected to the tower footing to reduce the tower footing resistance. 15 mm dia, 3.0 meters long, 10 to 16 rods, SVC ET25. What are the characteristics of an ideal surge diverter? 1. When the line voltage is less than the limiting value, the leakage current should be 0. 2. When the line voltage exceeds the limit, it should offer zero impedance irrespective of the wave shape, so that the surge voltage is bypassed. 3. Immediately after the passing of surge, and immediately after normal voltage is returned, it should act again as a perfect insulator. 26. What are the design considerations for LAS for EHV application? 1. Rate of rise of voltage. 2. The type of system, whether effectively earthed or grounded through an insulator etc. 3. The operating condition of the arrestor. 27. What is waving off voltage? Below this voltage, the LAS will not conduct. Waving off voltage should be greater than the normal voltage, power frequency. Otherwise there will be continuous flow of power frequency run current and hence heat and destruction. 28. What is the mechanism of generation of switching over voltage? Black circle making and breaking of electric circuits of large capacitance and inductance, for example transmission line. Black circle, the above constitute sudden release of internal energy stored in electrostatic form, in capacitance, and in electromagnetic form, in inductance, and causes switching surge amplitude 2 to 3.3 pu duration 1 to 10 milliseconds. The over voltage has high natural frequency component and damped normal frequency component. 29. What are the purposes of providing ground wire protection for transmission lines? 1. Ground wires are placed above transmission line, suitable shielding angle is provided. When the thunder clouds come near the trail line, since the base of the cloud has wave charges, plus wave charges are induced in the ground wire. These induced charges are drawn to the ground since ground wires are earthed periodically. Consequently, potential rise will be small and hence induced lightning stroke can be prevented. Hence the frequency of lightning stroke is reduced. 2. When lightning strokes takes place, traveling waves are generated, they move. Correspondingly, over voltages are induced in the ground wires, which will oppose the traveling waves and flattening of the high voltage curve on the transmission line. 30. Why ground rods are provided? 1. To reduce tower footing resistance. 2. A number of rods of 15 mm diameter, 2.5 meters to 3.0 meters long driven to the ground up to say 50 meters. In hard soils 3, they are interconnected and connected to the tower footing. 4. Reduction in tower footing resistance reduces the surge impedance of the tower and backflash over. 31. Give the equivalent circuit of a surge diverter VTH, open circuit voltage at junctions. ZTH Thevenin's equivalent impedance S, surge diverter. 32. What are the disadvantages of spark gap surge diverter? 1. Depends on atmosphere conditions. 2. Are cleaning to be done after surge flow? 3. For the same voltage peak, the gap to be set for lightning over voltage is lesser than the gap to be set for switching over voltage, and hence if we set a spark gap surge diverter for lightning over voltage, frequent flashover occurs for switching surge even if the peak voltage is lesser than the set value. 33. What are the characteristics of an ideal surge diverter? 1. When the line voltage is less than the limiting value, leakage current should be 0. Perfect insulator and impedance is infinite. 2. When the line voltage exceeds the limit, it should offer 0 impedance, and irrespective of the voltage shape it should bypass the voltage. 3. After the surge is bypassed and immediately after normal voltage is restored, once again it should act as an insulator. 34. How are the above characteristics are obtained in practice? One or more air gaps with a suitable non-linear resistance can produce the above characteristics.